We actually had this happen. There's a telco that had this happen to, where they had one CA hierarchy for pretty much everything. Well, guess what? It's easy to break in, right? I have one cert and I can get into anything. And so they've now broken that into multiple. And to your point, if something gets compromised over here, I can just rebuild that. And that's the way you have to think of it, is protecting your business assets, protecting different things, and keeping those trust chains unique so that if someone gets a cert from one of your other PKIs, they can't break into your enterprise, or they can't break into an ATM machine. They can't break that trust chain because it's different. There used to be a day in the browser, it would tell you, there was a color that said, hey, this is an extended validation cert. And I think to your point, and maybe we should raise a flag on this, is that somehow the browser needs to tell you, this is not an extended validated cert. This needs to, if you want to go to specific companies, you want to know that it's Microsoft. You want to know that it's IBM's website, not a malicious one. And the difference between an EV and a DV cert could be that. And there's not enough of that out there. And it's funny, you're seeing a lot of companies, they're all going away from the extended validation, which costs more money because there's no difference. Nobody knows. It's perceived the same. I love technology. You probably can tell I'm just passionate about it. And I hire passionate people too, by the way. So I have a big team. Anyone looking for a job, give me. But I love new tech. And so the ramping it's second nature for me. I love to dive in. Since I wrote software for a living, I deployed and I troubleshoot, it's just in my DNA. And so I can grab a new piece of tech and ramp very quickly.
In a world where everything has a digital identity, how do you know what to trust? Today, our guest, Eric Mizell, is here to tell us more about that. Eric Mizell had a long tapestry of a career, holding senior engineering positions in companies like Overops and Kinetica before joining Keyfactor, where he's the field CTO. He currently helps organizations secure digital identities in an increasingly connected world. And I'm excited to host him today. Welcome to the show, Eric.
Hey, thanks for having me.
Well, let's talk a little bit about your career journey. And you've had quite the journey from 3D modeling in the early days to engineering and now security at Keyfactor. Tell us more about how you got here and the story behind the pivoting.
Yeah, it's interesting. So it started off in virtual reality, back when virtual reality wasn't even a thing. And it led me actually to AutoCAD, which I'm still a huge fan of. And so I got my first job drawing pictures of wood fixtures, which I thought was super cool at the time. And these wood fixtures were for Talbot stores and Docker stores and Starbucks. We were building these stores, which was great. And year end, they promoted me to a project manager, which was awesome. So I was running and drawing and building and going to school. So it was all this stuff going on. And that was really my first exposure to a network. And it was the old Novell based networks, and it would crash every Thursday. And I was like, there's got to be a better way. And so I went and got an MCSE, and I took over the network and fixed those problems. And I was like, hey, I want to be a network engineer now. So I got a job with a startup. My very first startup was 5 guys in a house at a company called EW Group in Connecticut. So I was in Arizona at the time. I moved to Connecticut, built the network. And it was just 25 people at the time. And I owned version control since we were building software. So I owned version control, bug tracking, owned the databases. Everything was set up. And then I went to my boss and I'm like, now what? He goes, well, go learn how to code. So I went into a class on Power Builder back in the days of 4GLs, fat clients, thick fat clients, right? And so I took over. So I'm writing code. And my boss is like, you have to take over engineering. Every time I get a build from these guys, it doesn't work. Everything you do is good. So I took over engineering, and all of a sudden we started growing. We were writing software for insurance companies. And so that started growing rapidly. And then 9/11 happened, and the owners panicked. They sold to a company in Atlanta, and I moved there and we rewrote it in Java. And I got to, for the first time, build the product as a whole. So when I was writing code, I was writing with consultants. And when I went to write in Java, it was me now, lead architect. And I was like, I'm removing all the legacy stuff, no store procedures. We're getting rid of those. I want to be back-end independent. I need to do caching. Like, we started doing all these advanced work. And this is back in 2004. because I wanted to be able to scale, because that was what happened every time you go to a customer site and like, this has to be, every page has to drop in less than a second. The functions have to happen this fast. And so we were maniacal. And so I got into, writing heavy Java, and we were meeting and exceeding our SLAs. And I'm big on being 95% bug free. Like, we didn't want bugs. And that's very different than today, right? Like this whole build fast and break and fix stuff later. We didn't live in that world. We lived in build it right the first time. So I was loving that. It was going great. And then that company sold to Infosys. And then the Infosys folks said, hey, we're dissolving your team on premise and everything's going open overseas. And I'm like, great, peace, I'm out. And so I got my first job as a solution engineer with a company called Terracotta by happen chance, because I believed in caching in an application, offload my database and get high performance. And guess what? That's what these guys did. And it was open source, and their code looked a lot like the code I had written for caching. And so that was my first foray into that. Loved it. I went from being an everyday writing code to now I'm actually helping people solve problems, and I get to see a bigger picture of lots of companies and what they do. And it was an eye opener, because when you write code, you're kind of stuck in your little world. But now I'm dealing with all these big companies and learning what they're doing. And that was a huge shift in what I do. And then they promoted me to run the field. And then I went to Hortonworks, which was big data and Hadoop, and we IPO'd, and that was a fun story. And then I went to Connecticut and Overops. And then along the way, what's great about this role is that you work with a lot of great people. And my current boss and I had learned how to build and get product market fit and to build an engine. And he called me. He's like, I need you to come and help me do it again. So he invited me to join Keyfactor. And I'm big on wherever I join, I need to see value. I need to get excited about it. And I started looking at, PKI and managing of certificates and where these are. And you find out it's just everywhere. And, you start thinking about how we're securing the world. And he got really excited. And so I joined this company, and we have just skyrocketed. It's just amazing where we've gone. And so it's fun to look at, to draw on past history to get to where I'm at today with now taking this enterprise architecture to a security level. So it's been a heck of a journey. I hope that was what you're looking for.
Yeah, I know. I mean, I think it's super interesting, because I think that, back in the old days, like late 80s and early 90s, my first foray into IT was actually working with Adobe Illustrator and PageMaker and Photoshop and those kinds of tools. And, I remember like Stratosphere 3D and playing around with virtual reality, and I would let my Mac run for days to just to render. And it was somewhat ridiculous how much time it was spent to do those things. And but it was also the days of Novell NetWare. And I remember working for, at the time, Amoco Worldwide Engineering and Constructions, and running around dealing with Novell NetWare and having similar issue where it's like, it seemed like every week it crashed on a certain day. And it seemed to be like, why is this happening? And trying to figure that out. And then I did the same thing you did. I went and got, an MCSE as well, and started doing Unix stuff and everything. And it's interesting how the paths kind of went from something that was just, hey, let me get something done, to how does this all work? And then, getting more and more into the technical side of the industry. But I remember Power Builder too. Hey. And of course, my undergraduate degree, it was all about Java programming. So very similar kind of growth pattern, I think, in yours of what, I experienced as well. You were very much on the vendor side, where you were building products for customers. Yeah. Whereas I was doing solution architecture. I did that for IBM and those kinds of companies. So I guess that was on the vendor side as well. But I feel like I spent a lot of my career, in the buying side, which is a little bit different than the selling side, as far as like what you're trying to do and everything else, right? But I think that where you and I first met was probably dealing with certificates and identities on a telco network.
Yep.
While I was at Rakuten Mobile. We have these human identities, and then we have machine identities. And we have so many things that require digital identities so that we can do mutual authentication, other kinds of things. I'd love to hear how you think about secure digital certificates and Keyfactor and your role there. How does this look to you from, because again, you've looked at way more companies than I have. I had particular problems in my space and my industry, but I imagine there's a lot more to learn about digital identities than I know.
Yeah, it's amazing. The journey's been crazy because I think when I wrapped up my software engineering career, HTTPS was just becoming a thing. And so if you remember the days of hitting a browser and it was HTTP, and then when you went to buy, it switched. And if it didn't switch, don't use it, right? And that's evolved. And now, again, to your point, certificates are everywhere. And I think, I deal with companies who it's a checkbox. They don't really think twice about it. I just need a cert, not really caring how that cert's used as long as it just serves the purpose, whether it's a self-signed cert or I get it from a trusted CA or I grab it from a public CA because it's easy. You have companies like that, which is such a shame. And I think that's shifting because there's so many now. And then you've got new rules coming, which we could talk about at some point with the shorter life cycle, with post-quantum certs coming, that are post-quantum computers, and then you have post-quantum cryptography coming. It's changing the game. But the companies that know what they're doing, it's absolutely amazing because they've got different types of CA hierarchies serving different use cases. And so that's the proper way to do it. And you think about some of these big companies where you have enterprise PKI, which is your internal PKI, but then you have IoT devices and you have cash machines and you have ATMs and you have cameras and devices, and that's a different PKI. And you have a different PKI to serve M&A, and you have a different PKI to serve partners. And so you start to see like these different levels of trust, and the trust is what's valuable, right? That's the most important thing here is PKI is that establishment of trust. It's the identity that Eric is Eric and what Eric has permissions to access. And we don't want to give him access to other things. And so, like when you get to your company network and you log in, you have access to the private Wi-Fi within the company, but a guest might have access to the public. And so that's discerned through PKI. There's a lot of interesting things you can do in that world to make sure that trust is established and guaranteed.
Right. And I guess that, kind of having the different hierarchies for different levels of trust also gives you some amount of resilience as well. So if you have a problem with your CAs, God forbid you don't, but, if you do have a problem with CA, you don't take out your entire, CA architecture with, a single problem, right? So
you said that perfectly. We actually had this happen. There's a telco that this happened to where they had one CA hierarchy for pretty much everything. Well, guess what? It's easy to break in, right? I have one cert and I can get into anything. And so they've now broken that into multiple. And to your point, if something gets compromised over here, I can just rebuild that PKI, but it doesn't mess up the rest. And that's the way you have to think of it is protecting your business assets, protecting different things and keeping those trust chains unique so that if someone gets a cert from one of your other PKIs, they can't break into your enterprise or they can't break into an ATM machine. They can't break that trust chain because it's different.
Right. And this is like, I think like when we think about like telcos and manufacturing and, physical spaces, the devices that are hopping on the network may not have any human operators involved, right? But they need to interact with other systems. And so how do you assure that the identity of that device is the identity of that device? And then invariably, if you have a compromised CA and you're able to issue your own certificates, then you can impersonate that activity. There was just in the news today, and I haven't looked too much in it, but they were talking about like in the New York metropolitan area that they found like 300 servers that were like SIM servers that they were interacting with the network. And I'm super curious about how it was establishing trust, right? Because if they were able to log in to the network with these, SIM cards, fake SIM cards, which again, for me, I just think of that as another digital identity that's tied to a device so that we know where it is. But they had like burner phones and all sorts of ways to get this SIM farm to, send text to a bunch of people. They were doing swatting against, federal representatives and such. And it's super interesting how that can occur. And I'll look into it more. I don't know what's with it, but just because we're having a certificate conversation and how important certificates are to telecommunications and how we secure our comms, I'm hoping that there's no problem there, but I mean, I can totally imagine that there being problems there, especially with the radios that are, going online and such, right? So
I think that's the biggest challenge is protecting your CAs, right? Because bad actors are everywhere, internal and external. I think that's what people forget. And so you have to make sure your CAs are protected, because if you have a bad actor issuing certs internally and then taking them externally, that happens, right? So part of good PKI is good security around it and good processing controls.
Yeah. And I think another incident that happened a few years ago was I think Microsoft lost control of one of their certificates, one of their code signing certificates.
Yeah.
They were able to, sign code as whatever company.
As it was Microsoft. Mm-hmm.
Yeah. And so
it's funny you mentioned that. I did a talk on this at a couple conferences, but people think that because a code signing certificate is expired, that you can't use it. But lo and behold, you can. You can sign with this still. There is some hacked code on the web that allows you to sign a certificate, and it ignores looking at the expiration date. So again, why you need to protect the private key. You should never have a code signing certificate that has a private key that's exposed. And if you leave that private key with a certificate in a GitHub, someone's going to get it. They're going to use it. So private key should always be in an HSM.
You can delete it. You can delete it, and it's still in the history of the GitHub. We just have to go to the right release to go get it
100%.
And so the other, I think that, the other place that people really fail with certificates is on their web servers and their servers that are connected. And I remember back in the, mid 2000s, like 2005, 2006, when I was first getting into cyber and securing IT systems on Navy networks, one of the STIG, Security Technical Implementation Guidelines that, DISA has, you had to go make sure that your private keys weren't on all your servers. And even, you fast forward, another 10 years, and that was something that I still saw happening, in PCI environments in 2018, 2020. And I imagine it's still happening today, where people are leaving their private keys on their servers. It's a huge problem. I don't think people really realize like what kind of trouble you can cause by just having a private key laying around, or even like your SSH to log into a system, not securing your private keys that are on your desktop to SSH into a device. There's lots and lots of stuff.
Don't get me started on SSH, man. I love it, right? It's a great tool, but the keys are perpetual, right? So I still have keys from past jobs. You got to make sure you get rid of that stuff. Yeah. But to your point, it's interesting. I've worked with some customers where they put all their private keys. I can't make this stuff up. They put all their private keys in a directory on the network with the same password. Like, wow. Why would you do this, right? Private keys have to be protected. They are your biggest asset. When you think about PKI, your root key material, offline root, protected. Issuing CAs, in an HSM, protected. And then the keys that they produce, the private keys they produce, need to be protected. And if they're installed in an application server, it's in a protected area. Like a Java key store has a password to it, and you have to, credentials to get to the box is secure. But leaving them on a network, in a GitHub, on someone's laptop, and I see it all the time because they don't have certificate lifecycle management or they don't know any better, and people just start downloading them on their laptop, and now someone gets your laptop and they have the keys to the kingdom. Pun intended, right?
Absolutely. I think that in my latest experience with certificates and PKI is that we had our own CAs, and I felt comfortable about it, having our own CAs and such. And we were issued eSIMs and those kinds of things. We had we had people auditing our CA infrastructure and that kind of stuff. But, I think for most folks, I think there's a lot of nuances in this that you're probably, if you're not in a regulated industry, you're probably not going to have like a third party audit you to make sure that you're doing it right and doing, maintaining all the security. Are there any, other than, hey, take it seriously, make sure you understand what it is that you're doing with the CA. Should people be doing their own CAs, or should they be outsourcing that work to someone else that knows how to do CAs? I mean, how would you advise someone on managing? For sure.
Yeah, it's interesting. We all grew up with the Microsoft CA, click next, 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 next. I have a CA, I'm done, without best practices and the like. And it's that checkbox mentality. Outsourcing it, I think PKI as a service has some value depending on the vendor. And I don't want to get vendor specific, but you have to be cautious of, are you getting the same check, next, 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 done? Good PKI practices starts with, the CPCPS, right? So it's my certificate policy and rules and governance of how I'm going to operate it. Because if you don't have that, then it can become the wild, wild west, meaning I can issue a certificate that has every function on it. It can be used as a code signing cert. It can be used as a server cert. It can be used as this. And then that's, again, the keys to the kingdom. And if you've seen, we're probably going to get to at some point, the shortening life cycle of public search from a year down to 47 days, which is huge. But the other piece to that is typically when you get a public cert, it allows you to do server and it allows you to do client auth. And that typically those two are in there. Well, that's now no longer going to be allowed. And the reason is that client side of it allows you to do client auth. And now I have an identity as a client to a server what I shouldn't have. So they're splitting that away. So now, again, good practices are you server search that is for a server application should only be that. And if I need client auth, it should only be client auth. And so that goes back to good certificate policies. And so, we highly recommend if you're going to set up a new CA and you want to do it right, just set up a good practice. What am I going to use the certificates for and what they should allow? And there are NIST standards for all of this. There's a great, you go to NIST and you get a great document that tells you, if you want this kind of cert, here's the EKUs that you should allow only. And that way you're protected. That way you don't have certs that are used improperly and you don't have the Wild West and you don't have a mess because, the world is changing as we know, and the post-quantum computers are coming and the cryptography is changing as well. So there's really no choice on changing cryptography. If a post-quantum computer never showed up, NIST is still deprecating RSA and ECC as of 2030 and then no longer supporting it as of 2035, which means browsers won't support it, apps won't support it, networks won't support it. And so we're going to have to change. And so now is a great time to do it right. Like, let's learn from the past and build it right the first time. And then you're going to have a much better experience and have less opportunity for breaches, if you will.
Right. And I think when I'm listening to you, I'm thinking resilient architectures, identity or PKI infrastructure that is limited functionality, least privilege with respect to what you're using your certs for and what the class of cert is, what it's meant to be doing. So it's kind of like doing role-based access control in the human space, but you're really doing it role-based access control for your machine identities, that your digital identities for whatever purpose that you're trying to do. And it feels like we, as cybersecurity practitioners, we know what that is, right? But it also sounds like we need to be super cognizant of vulnerabilities that we know are going to show up in the future. Like you were talking about post-quantum cryptography. And with respect to post-quantum cryptography, it's like we need to start using that now because invariably we're going to have drives or other kinds of things that we have encrypted today that may have information that is incredibly important to us, right? But, in a post-quantum computing world, that cryptography is not going to be useful, and we're going to be able to break that cryptography. So we need to get ahead of encrypting what it is that we think is important now, so that it can't be exploited later.
100%.
Quantum computing, right? So
100%.
It is a problem that we need to be working on today. We need to be thinking about how we're going to achieve post-quantum cryptography, get rid of those old encryption schemes that we've been using for a long time that have served us well, but it won't serve us, in the next 10 years, is what I'm going to say. Yeah,
you're right. And the other piece to it too is, it's the PKI best practices. So you think about a bad actor, what's the first thing they're going to do? If they get into your network, which is happening either through phishing or internal, the first thing they're going to look for is what's on this server. SSH keys. That's the first place they go. What certificates are there? certificates are stored in certificate stores. Sometimes people don't change the passwords, like the generic password for Java key stores, change it. And if they don't change it, then someone's seeing what's available. And if you have bad EKUs in there, and I have client offserts and stuff that allows access, that's how bad actor gets from server to server to server to devices to systems. So you got to take advantage of this change, build good PKI, and then yes, you need to start thinking about the post-quantum cryptography, which is, NIST has the standards out. There are, like our PKI, JPCA supports those today. People can start to play with those and start trying things out. HSMs are coming online. OSs, Microsoft's a little slow, but they're coming online. Linux versions now support it. Application servers are starting to support it. So you start to see the evolution. And so you sort of said it best. Data classification is critical. What data do I need to protect now that could be decrypted later if I don't do something now? And so you want to focus on the high value assets first, because there's some stuff in your network that probably doesn't matter, right? And so we're not as worried about that, but the things that are high value, you certainly want to get protected sooner.
Absolutely. I think that I have been involved with breaches. There was an open S3 bucket and someone downloaded an encrypted backup. And I was thankful that they downloaded an encrypted backup, not an unencrypted backup, right?
Yeah.
And that saved my bacon, way less threatening of a problem than it could have been. But we've been talking about post-quantum encryption is like, we got to be thinking about that because, hopefully that encryption was good for the future. But, invariably, there's something we got to worry about. We've talked a little bit about some war stories. Do you have any cautionary tale war stories that you can tell us about there?
I do. I have a million of them, but I'll give you a couple good ones. So I think the biggest challenge for most enterprises, and I think a lot of people are there already, but a lot of them I've worked with have no visualization of the landscape. So their cryptographic posture, if you will. And when you don't know, what you don't know is what is the problem. That's the edge. And so this company had an application that sent alerts when it detected breaches. So its job was to detect breaches in real time and then send messages if something was happening. It detected a breach, but it was connecting to the alerting system and that certificate had expired, so it couldn't send any messages. And it was trying to send messages for like 3 weeks. And of course, the breach went on. And they got fined, and it was big time in the news. But they didn't know the cert was there. And that's the biggest problem. And they didn't have any issue. So I think I would envision that anyone on this that's listening to this podcast that has any kind of security background and does PKI realizes that when an app has an outage, most people don't realize it's the PKI like that. And I've actually had that happen to me. I had an app running and everything was great. It was all the logs were fine. Everything's up and running, but we couldn't connect and we didn't know why. It took 5 of us like a couple hours to sort out that the cert had expired because there's no visualization. So visualization is key.
Yeah. I can't tell you how many times I've been bitten by certificates expiring.
Yeah.
It's almost, it used to be that I used to feel like every time there was an outage, it was because someone had a cron job with root and the root password expired and it was like that. Now it feels like every time there's an outage, there's a certificate that wasn't being managed properly and it expired. And the interesting thing is that we have tools that allow us to check for certificates and enumerate. I think even like Qualys has a free tool. You can just use their SSL cert stuff inside their capability and scan all your devices for your SSL certs. And it'll tell you when these SSL certs are expiring, if they're self-signed or whatever. And no one seems to put that together. And then this goes into the whole thing where people start creating certificates that never expire or expire in 10 years and 20
10-year
years.
cert.
Yeah,
it's not my problem. I will be here in 10 years.
Yeah, exactly. And I do want to talk about the shortening life cycle of the encryption keys, because I think that's incredibly interesting. I also think that the prevalence of self-signed keys, it's like everything that you do, like you set up a Kubernetes environment, you spin one up, and it's all being, all the keys there are being self-signed, which I'm glad that we have certificates, but well, I kind of feel like it's the same as having default passwords set up everywhere, just having self-signed certificates all over the place. From a threat perspective, do you think of it the same way, or having more different self-signed certificates in different places, is that kind of feels resilient, but it's also something that you would have to manage inside that like Kubernetes cluster or whatever?
So yeah, you have a couple flavors there, right? So self-signed certs as a whole, just a bad practice because there's no governance around it, no visibility, and it's going to expire at some point, right? In a Kubernetes cluster, a lot of people, there's a couple flavors there. A lot of customers we work with, you can sign the inbuilt CA with your CA. So you have a trust chain there. We recommend, we have the product EJPCA, which can issue those certs. So that way you can have a centralized CA for all your Kubernetes clusters. We've seen such a variance because what happens with the Kubernetes cluster is you have apps within the cluster that want to talk to other apps, and you have ingress egress points, which are the longer lived certs, which could be a public cert or private cert that need a proper trust chain. And so we provide those, but if you don't have that microsegmentation sorted out, you could have clusters that don't trust clusters. And we've seen customers that have, 50 clusters and 50 separate CAs, and it's a nightmare. And so they're like, this whole thing is not working. And so we move them to one external CA to support all those clusters that's trusted. They get audit logs and compliance and those things. So there are ways to solve it, but I think the problem with anything that's new, Kubernetes and now AI, right, is security is a secondary thought. And that's the way it's always been with anything. Security is always an afterthought. We try to wedge it in later. And there's bad practice at the beginning because we need to get the new tech in, and then it sort of gets there. And so Kubernetes is caught up. We've got a lot of tools for that now. So Cert Manager being one that a lot of people use for both MTLS and ingress egress. And you use a trusted chain, and you have a proper CA set up for that. So that's the way I view that for the way to go is you need to have a proper CA in place and use the tools properly. Because if you just go with the inbuilt, the MCLS side, you could probably get away with, but the ingress egress, you cannot. Because that's how apps talk to each other. That's how you get into the cluster, and it's how it's connected to databases. And you need to know that's coming from your trust chain with proper controls.
Right. When we start talking about like IoT and connected systems,
Mm-hmm.
I mean, there's like millions and millions of devices that we're trying to manage the digital identities on. We talked a little bit about like EJBCA and, having your own certificate. I mean, and we've talked about breaking it up into different PKI infrastructure so that you can, limit the blast radius and such.
Mm-hmm.
But are there any, with respect to like managing millions of digital identities, and it sounds like a lot, millions,
Yes.
right?
It is.
But in reality, we have billions of connected devices and billions and billions of connected devices.
It's actually frightening.
It's frightening how many connected devices we have. And just think about your phones as a connected device, and your Apple Watch, and whatever it is that you have that's electronic. All of these things are participating in with digital identities. Just to begin that journey of managing their digital certificates, we've talked a little bit about that. Organizations need to get beyond next. Here's a CA.
Yes.
But
Yeah.
you gave some guidance on NIST practices that are available.
So from an IoT perspective, I think it's interesting because, again, security is an afterthought, as always. And a lot of people just put a long-lived cert on there. Let's put a 10-year cert on it, put it out there in the wild. How long is the device supposed to live? And then we're done. We wash our hands clean of it. And as long as it doesn't get breached, it's fine. There was a time there was no certs on them, and they were getting breached constantly. People were breaking into them and watching, your kid through the baby monitor, that kind of crazy, right? But what's starting to evolve is managing the cert on the device and renewing it. So the newer devices have a TPM in them, and they have crypto libraries in them, and then they will renew the cert on a yearly basis, which is at least better. And at some point, it'll probably reduce that timeline. And that's the proper way to go, in my opinion. The toughest part is it depends on the device. If it's a monitor in your house, does it matter as much? But if it's a camera in a secure facility, you bet it matters, right? If it's a car on the road, we do a lot of cars, a lot of manufacturing where you get a birth cert in manufacturing, and then it gets out in the wild, right? And it's turned on for the first time, and it needs to get a proper new cert, and then it needs to be renewed, and you need to do secure firmware upgrades. There's so much involved, and it depends on the product. But I think the best advice I could give is security needs to be thought up front. Interesting story. There are some new bikes, motorcycles, like scooters and cars being manufactured. I don't know if you saw, there was a whole hubbub around you're no longer allowed to work on your car. I don't know if you saw that coming through, and people are getting all up in arms. Well, what's happening is that they're trying to combat against aftermarket products made in other countries. I won't mention. You probably know them. So basically, we're doing cert off now. So you get a part from the manufacturer, and it cert offs and says, yes, you can use this device. If the cert doesn't get authorized, it can't be used. So that's the whole story behind you can't work on your car anymore, because you have to take it to the dealership so they can put a certified part on it that authorizes. So you think about every component in a vehicle has a computer chip on it now, and it's authing to the car to say, I'm a trusted part from the manufacturer, not an aftermarket part that someone could put on.
And I feel like people don't understand the integrity parts of this.
Yep.
Right? That it's like if you have a foreign part that isn't authorized and you go and you put it into it and it's participating in the control of the vehicle or information about the vehicle, you definitely don't want a third party actor or another country,
yes,
injecting into the safety of your vehicle.
Yeah.
And there's a trade-off there, right? There's a trade-off there. And especially in spaces like telecoms. One of the things I remember early in the Russia-Ukraine war, very early on, Russia took over Ukrainian telecom system. That's one of the things that they did, right? And then, but the crazy thing that was happening was that there was no encrypted communications that the Russians were using. They were just unable to communicate, securely. And I think that we tend to forget that we need integrity communications. We need that communications to be secure. We need to know it is who they say they are, and that the communication channel is secure so that events aren't injected into it or commands are injected into a system that cause the system to go and do the wrong things or fail. And part of that is like making sure that you're authorizing something to be on your network, whether that network's inside of a car and it's chips communicating on that path, or even your standard walkie-talkie kind of communications that you don't want your adversary to listen in on, right? So there's lots and lots of places where we're using certs.
It baffles me every day. And we've seen examples of cars that have been hacked into and shut off driving down the road and the like. And so to your point, you have to have an identity of who's allowed in and who's not. It can't go any other way, or it's just a recipe for disaster. Put an autonomous car on the road that someone can hack into. Can't have it.
Bad idea. And then shifting gears to like browser security, and we have, just because they're part of that, trust chain, right? And given that employees spend so much time in browsers, and we were talking about this earlier, how it used to be that you didn't really care about the security of your communications until you went to an e-commerce site, then you had to make sure it had HTTPS.
Mm-hmm.
How do you see the intersection of identity management and browser security evolving?
It's interesting. And I think it even extends to apps, right? Because we're big into apps on our phones as well. But it's funny because the evolution of biometrics and then multi-factor has been like the way to go, right? It's been awesome that I can get a code, you type in the code and you can get in, or you have facial recognition. There's so many different facets, but what's happening is that there's a huge movement to move away from passwords because they're the riskiest thing we have. And the challenge is people use the same one, or there's an easy one. I don't know about you, have a password vault, which is insanely full of different passwords, right? I work with a lot of the big banks that want to shut off passwords, and whether you use like a YubiKey or a TPM or something that identifies you with a certificate on it. And the reason I'm a big fan of the certificate because it expires, right? It has to be renewed. Because if you go, it's like some of the other technologies don't have an expiration. So now it becomes another open-ended thing, right? It has to have an expiration. But the biggest challenge is that people lose their devices. They, you know what I mean? So the combination there, I don't think is completely solved yet. I think the MFA has been huge, but it would be great. But what do you think? But I'd love to be able to log into my phone because you biometrics. My cert is my identity. And a lot of the apps that are out there, there is a cert in there. You just don't know it. That's your identity. And then it's matched with biometrics. So it's a facial recognition and you can get in. Some people use the biometrics with your facial recognition and then it's MFA, whether it's code to your text, which is at risk now because people are hacking those, or you're using a authenticator app, which again is another annoying thing. You have to go in and get the code. But you know, it's going to be interesting to see where it goes because I think there's always a weakness somewhere. That's the challenge. I don't think there's any way to find a perfect tool because there's always a way to hack it. It seems like we have bad actors that are finding ways, but it's going to be a combination. I think as with YubiKey, biometrics, MFA is already there, but it's found its weaknesses. But we want to get to something that's simple and secure. And I think we're seeing evolution. I see a lot of companies spinning up in this space. So it's going to be fun to see where it goes and how it evolves.
Yeah, I think that, just the way the industry's moved, we talked about cars and having, parts in the car that allow you to participate in the network and making sure that that part is what we think it is, right? And it can participate securely on the network. I kind of think of like browsers the same kind of way. Today's world, we have all these SaaS apps that we have deployed. And on the server side, they have the secure search. So they've told us who they are.
Yep.
But on the browser side, we're not really seeing that. Well, we are. We are seeing it. I think that, like you said, it's not incredibly apparent to us that we're using biometrics with the certificate that's on the app that allows that communication to be secure. And we're authenticating the client side as well and mapping that to a human identity. So we're not seeing it, but it's happening. But those same controls that we have to secure the communications, right, between the app, the browser, the app that's being secured, and that server, we've lost kind of visibility of what's happening in that space, right? And from a security perspective, we were always thinking about attacks that are happening in that secure channel, right? And we used to pin our IDSs and our IPSs with certificates. And we had all these accelerators that were on our IDS and IPSs so that we could encrypt and decrypt in real time, the communications. And we kind of lost that, in the browser to the SaaS app kind of communication channel. For me as a cybersecurity practitioner, I kind of feel like it's a weakness because now we have the ability to have covert communication channels to different places and it feels secure, but it really isn't secure. Do you have any thoughts on that? Or
so, all of it's done with a secure certificate. So you still have when I'm connecting from browser to SaaS, you still have HTTPS. Yeah.
Yeah. And you have a secure communication channel between the browser and the server.
Yeah, for sure.
Even a malicious server can have a Let's Encrypt certificate on it that allows them to be valid, right?
Yeah.
But what I'm worried about is like how much traffic is over HTTPS today that your security team can't really look at as it traverses the network, where our traditional security stuff was happening. Now we're just kind of like, you either have to do it on the server side and hoping that the servers are somehow, people are taking down the bad servers and that those threat intelligence stuff is all happening so that you don't have.
I get where you're going.
In that browser, that's, like 80-90% of our work happens in today. If it's going over a secure channel, it's hard to see what's going on in there.
Yeah.
Right.
So it's interesting where you're headed. There are so many malicious sites that look the same. They take the same brand, the same thing, and one letter's changed or something's different, and you don't know. It's funny, we talk about this a ton because if you think about the way public certs are, you have an EV cert, you have a DV cert. So EV is extended validation, right? DV is domain validation. Anyone can get a DV cert, which is it lets encrypt. All I have to do is prove I own the domain. You and I can spin up our own little website and get it as close as we want to some company and then send out a bunch of emails and get people coming there. But the extended validation means they have to validate the business, the people, and that means a person has to do this validation. There used to be a day in the browser, it would tell you there was a color that said, hey, this is an extended validation cert. And I think to your point, and maybe we should raise a flag on this, is that somehow the browser needs to tell you this is not an extended validated cert. This needs to, if you want to go to specific companies, you want to know that it's Microsoft. You want to know that it's IBM's website, not a malicious one. And the difference between an EV and a DV cert could be that. And there's not enough of that out there. And it's funny, you're seeing a lot of companies, they're all going away from the extended validation, which costs more money because there's no difference. Nobody knows. It's perceived the same. But I think you just hit something here. It's going to be more and more important. There's so many malicious sites and everyone's falling for it. They're putting their creds in there. They're falling because there's nothing to tell them different except for the little internal stuff we do, like, hey, this is not a trusted email, or don't click, you know what I mean? But people are still clicking.
Agreed. Yeah, so like definitely having policies around whether you're going to accept a extended validation cert, or that would be definitely a push in the right direction with respect to secure browser communications. And then domain validated certs would be a lesser trust category, right?
Yeah.
And being able to differentiate between them. But it only works if the companies that we do business with all the time are using extended validated certs which we should expect, as buyers.
We should expect
that if it's a legitimate site, that it's going through some sort of extended validation.
Mm-hmm.
I think it's a really good point there. We can't get out of a call or talk without talking about AI, right? So I saw some, good posts about AI and browser identities, because there's a lot of stuff going on with AI today, right? So how do you see AI and machine learning changing the game for attackers and defenders in the identity access management and certificate space?
I'll tell you what, I've already seen some articles on the attacker side where the AI is intelligently making decisions on how to attack. It's got 5 or 6 decision tree points and they can decide on demand. And what's interesting is I don't think a lot of people know this or even pay attention, but even our good friends at Google get hacked. And so my wife did a web search and she clicked the sponsored link and it took her to a malicious site. You didn't expect that from a Google search, but it figured it out. And then I don't know if you saw recently, if you use summarize my email in Gmail, it was maliciously putting stuff on people's desks, laptops. It was figuring out, oh, your Windows, your Mac, you're this, attack this way. So it's giving a lot of tools, unfortunately, to the bad actors. Of course, now on the positive side, we're going to see a lot of new things evolve, a lot of new tools around on the AI side to try to stop the bad actors. So the toughest part is, it goes back to what we talked about. There's so much done with phishing. Phishing is the biggest tool for an attacker because they just catch people that aren't reading and they just click the button and give away credentials. Hopefully with AI, we can stop a lot of this stuff, more of it. But it just keeps evolving. I think that's the biggest thing is you get one thing plugged. It's like a dam with a bunch of leaks. You plug a hole, a new one pops, Absolutely. And I don't think there's ever going to be a perfect solution because you have AI on both sides. So,
I think it just gets faster, right? It's just a faster evolution. We're hoping that the defense is evolving as quickly as the offense is. But I think that a lot of the controls that you have available in your network or technology that we have controls for, I think it can help in those like the phishing attacks that are being AI generated and pushed out.
Mm-hmm.
It's hard for that if you don't have technology that's helping the user, the human do it, then having AI get involved isn't going to make it better, right? And
the best advice is don't click on something that you don't trust. It just doesn't get any better than that. Like, we have control over our own fate, right? I always tell people, because we have to do this internally, you probably get this at your company at some point where they do phishing attacks to test. And I teach my kids and my wife, I'm like, don't click on anything you don't trust, text or email, because you just don't know.
Yeah.
Go right to the website. Don't even click on it. That's your best defense. But AI will evolve, and it's going to work both sides. But hopefully, on the positive side, we'll get more.
Right. Well, you've successfully pivoted across different industries and tech paradigms. How do you handle ramping up in a new technical domain when you make a career shift?
Man, I'm an avid learner. I love technology. You probably can tell I'm just passionate about it. And I hire passionate people too, by the way. So I have a big team. Anyone looking for a job, ping me. But I love new tech. And so the ramping it's second nature for me. I love to dive in. Since I wrote software for a living and I deployed and I troubleshooted, it's just in my DNA. And so I can grab a new piece of tech and ramp very quickly. Anytime it's just how it works for me. I'm built that way. So yeah, that's how I ramp. It's just dig in, just begin. And I'm maniacal because I don't care how many hours it takes. I just get into it.
Yeah, I'm the same way. And I think it's so crazy how folks are trying to make careers in IT or make careers in cyber, but they really don't have any passion for it. So just this 9 to 5 job for them. Whereas for me, I'm the same way. I can get in there and I can just learn something just because, and I learn something every day.
Yes.
And I love that about computing. I love that about technology, that there's always something new to learn. So I think if you love it, I think it just makes it easy. So I'm going to ask you a question about technology trends that you didn't think were coming along. But my go-to story is, I remember I was at Apple and, what I thought was going to be incredibly useful was like S-MIME and chains of trust and making sure that the email that was going from me to you was coming from me to you. And this is like 1993 or 4. And I thought that was going to be the big tech at the time. And someone gave me like NCSA Mosaic 1.0B on my Mac, and I'm like double clicking it around and going to all these little really crappy websites. And I remember taking it, putting it in the trash, emptying the trash and saying, this isn't going anywhere. I remember that, right? It wasn't going to go anywhere. It was all fat apps at the time. Whatever. So has there been a new technology or trend you initially dismissed, but later realized you were wrong? Do you have one of those stories?
I do. So when I built my first network, we ran everything on bare metal and we sized the servers according to the tech that was going on them. And I never worked in a data center. Remember I told you I only had my myopic view, and then virtualization came around. So, the VMwares of the world and stuff. And I'm like, who the hell needs that? That's a waste. Like, why do I want to slice up a box? And yeah, it got huge. Clearly was wrong, but I didn't see it from an enterprise perspective of, if I have a data center, let me buy a bigger box and slice it up because it takes less space. I thought, why not buy a 2U that serves that use case? Well, then you need a ton of 2Us instead of one big one that you can virtualize. So yeah, I missed that one. I whiffed big.
Yeah, that's a good one too, though. But yeah, if you're in the enterprise, if you back in the old days, I remember we would wait months for servers to be delivered.
Yep.
Months for servers to be delivered. So for us to get our app installed and stuff, we would have to think about the supply chain and whether or not that server is going to be there. And then if later we had to worry about whether we could get replacement parts for it. That was like the bare metal data center days. That was no virtualization. That was a nightmare. Today, but yeah, I could totally see missing that as well.
Yeah, I whiffed.
Well, anyways, hey, Eric, it was great having you on the show. Thank you for sharing your point of view with us.
For sure. Thank you for having me. This is great.